Welcome to Industrial Systems Engineering in the New Era of AI, Episode 4. We've been really going through a journey of rediscovering the foundational challenges of our industry, all the way through to the rise of what ARC calls Industrial Data Fabric and the domain-specific innovators and startups that are really driving a lot of the momentum. Now, today we're going to take the next logical step in our conversation. First 3 episodes, I talked to a long-time innovator in the industry, and today I'm going to talk to another. So today we're going to explore how all of that AI-ready data is going to really get activated. And I'm thrilled to welcome Vatsal Shah, co-founder and CEO of Litmus Automation, a company at the heart of this transition, to discuss the critical link between the data foundations we've been talking about and the new wave of reliable agentic AI. So welcome, Vatsal.
Absolutely. First of all, thanks a lot, Colin. Yeah, thank you for having me. And this is I'm a huge fan of everything that you do. And for my commute, I listen to your podcast all the time. So I'm really happy to be here. Thank you.
Great. Well, I'm glad to hear some people are listening to the conversations. I enjoy them, and I hope we're going to have a great conversation again today. So maybe let's start by the why, right? Let's ground this in reality. Before Litmus, you were an industrial automation engineer, I believe. And what specific frustrations on the plant floor, integrating systems from, Rockwell, Siemens, Yokogawa, made you realize a new approach was needed?
Yeah, absolutely. So I did start my career in the industrial side, automation engineering side. The first job that I got, it was just an internship itself, was in a power plant. So as you can imagine, power plants, they are probably as messy as you can imagine. Like, they have a bunch of these old DCS systems and bunch of these old control systems. And I was always curious. It was a short internship. But the idea that I realized is everything that we have been doing, it was created like so many decades ago. And they kept on running on it until it hits the ground. That was my first exposure to control systems. That was my first exposure to all this DCS and HMI and SCADA system. And again, not even SCADA. It was like a bunch of these buttons on the panel. That's what we used to deal with. And then, like, after a little while, I got a job on industrial automation engineering side itself, doing the real stuff. And the idea was that the first day of my job, it was like, okay, introduction, here is your laptop. And what you're going to do is, here is your PID diagram. Take that PID diagram and put it on the SCADA screen. And here are the 5 different reference documents available. Just go ahead and figure it out. It's like fresh out of university, and they just throw you in there because this is the grunt work that you have to do. You do it. But that just opened up so many possibilities for me. How manufacturing operations were working. How to understand what they were doing, why they were doing it, why system integrators were suggesting this. Sometimes we were all lazy. Sometimes we were quite innovative. But that gave them the exposure that I was looking for. One of the biggest moments was early in my career, I was working on a whole lot of oil and gas, a couple of Russian oil and gas, Middle Eastern oil and gas, and a couple of food and beverage customers itself. The idea was there was not a single vendor on those facilities. They were greenfield, but there were Yokogawa systems, Siemens system, Omron systems, and we had to do with a Fisher-Rosemount. If you are ever in oil and gas, Honeywell and Fisher-Rosemount, their sensors, they are as ruggedized as possible. So all different protocols, all different things. And when we got the project as a SCADA interface, we used to develop Excel macro scripts to get data out of those and make it available to our system. 6 guys did it for 4 months because we had to reverse engineer the code that they were giving. And the first line that I wrote, it is in the napkin before starting the Litmus itself, was, what do we want to be? We want to be Google for industrial data. Make it searchable, make it awesome. I just found that note recently again, after like 9 years. That's, again, saw the problem that there is no one unified access. There is no one unified way to do something with the data. And how do we create that beautiful interface sitting in Silicon Valley? Like in the world where user experiences are driven by social media companies and user experience are driven by software as a service companies. How do I take all of this innovation and bring it to manufacturing world? that usually just suck. They suck for manufacturing interfaces, and everything that they've created, it just built with a specific mindset under consideration. So founded Litmus, dumb, naive, young, and jumped on it.
Yeah, I mean, if people are hearing me chuckling, I started off as a chemical engineer in process control in process investigations, and so you kind of stirred up some old memories.
Yeah.
As you were talking through that experience. So let's talk about your company. You champion Industrial DataOps. So how do you define that, and how does it differ from just collecting data or building a massive data lake in the cloud?
Yeah, absolutely. So, like I think the word changed over time, which is like industrial edge platform and industrial edge data platform, industrial data platform, industrial data ops platform. It's a flavor of the week.
Industrial IoT.
Industrial IoT, and like M2M was the first wave in 2015, and just IoT came in and everybody jumped on that bandwagon. For me, it doesn't make any difference. Like, all we have to understand is customers are looking for collecting data from where? Their existing assets. How do they collect that data? How do they contextualize it? How do they store it? How do they analyze it? How do they integrate it to the broader ecosystem of industrial or IT products, IT cloud ecosystems? How do you integrate all of those things, and how do you simplify that journey? That might fit into one of the spectrum of like a product categories that everybody keeps on talking about: data ops, data platform, foundational data platform. It just, for me, manufacturing data is better in the hands of company that can drive a whole lot of value. That might be cloud data fabric, as you are championing, as well as like cloud companies, AI companies, machine learning. They need this data. How do we bridge that in a way that they can readily consume? That's data ops for me. And I understand, originally in 2017, nobody was talking about it. Cognite and few other companies, they started talking industrial data ops a lot. That was I think one of the initial companies to talk about it, to model. And then, of course, it picked up as a brand new category after that point onwards. But it just, again, how do you solve the problem matters.
Yeah, I think I don't really want to get into deep discussions around data platforms versus data fabrics, etc., right? Because I think to me, it's a label, right?
Yeah, it's a label.
I tend to use the term fabric because I don't think anyone has a platform that is comprehensive. So in most cases, people are having to weave together, right, multiple components. And so I prefer at least in my mind, I visualize a fabric being woven from multiple systems, right?
Exactly.
So I tend to use that as my personal visualization of what needs to happen. I also like to break down some of the traditional silos. So a lot of what I've been writing about is really the fact that OT, IT, ET, if you bring in the engineering and technology side of it, and data science actually have a lot of common interests, but they call them different things. They optimize for different things. They're coming from all have different preferences on their platforms, right?
Absolutely.
And so I tend to use the concept of a fabric just to get everyone to step back and say, all right, maybe we have to take a different approach. I think what everyone has in mind, and why you reached out to me, was this idea of context engineering that, I think Rick and I probably said context 30, 40, 50 times in those first 3 episodes without really, we did kind of sketch out what we meant by context, but I think you really want to take that a step further and talk about contextualizing data and where that needs to happen. So in my recent blog on context engineering, I kind of talked about the necessary evolution from prompt engineering to context engineering, which we'd kind of been talking about, but I hadn't quite put it in those terms. And so I think thank you for reaching out and kind of inspiring me to write that blog. But what I'd really like to understand is, how does you think about what is driving the market, I would argue today, from and let's call it industrial data ops from now, for folks like you that do a really good job in that space, to take the next step and make that data contextualized for AI-ready consumption, wherever that may be, whether it's IT asking for it, it's being used by OT on the edge, or you've got data scientists that need some subset, and it may not even be real-time access, but needs some context for some of that data that we tend to think we own as OT on the factory floor. So I'd love to get your ideas on what is this context engineering approach and how are you using it to shape what you're doing and your roadmap moving forward.
Absolutely, yeah. Now, happy to jump on it. So, let's think from a two different point of view. The point of view number one, which is evolution of AI systems on its own. If manufacturing and industrial doesn't exist, or manufacturing has nothing to do with AI is already evolving as of this moment. Which is, it started with prompt. I still remember my first prompt that I put on ChatGPT. I still have the screenshot of it. The idea was, you give some input and it is giving some output as a part of this generative AI element. The moment that got introduced, the chase for everybody else was I want my own relevant information out. Rather than you telling me what you know from 6 months ago or a year ago, I want the information in a way that I can use it right now and it's 100% relevant, and I don't want to keep on editing it myself. So the first generation of product was introduced as a RAG, which is, of course, like it goes back, make an enterprise call, it's going to get something out. The second generation opened up from RAG, and then MCP servers are opening up, which is much more like REST API extension on the top of the data itself. So the idea that evolved is, give me the response which is relevant to me rather than anything else. Again, nothing to do with manufacturing or industrial. It just context engineering evolved as understanding the data behind the answer that you're giving me. Now let's go back to the reality. If you go in a manufacturing site, like I was just in one of the largest tools manufacturer in North America. We use it. I have a bunch of them. Half of my garages is that product. I looked at it, and they had close to 35 CNC machines, and they had close to 100 SKUs of product that they were manufacturing for research, and close to 40 different assembly lines where they were making the exact same things again and again. Today they are making this batch of product. Tomorrow it might be something else. So let's take an example. Today they are making drill, and then there is an impact driver that they make. So Litmus Edge was already running on a big screen on the top of it, and now they are asked us, how would you introduce AI to solve this specific quality issue that we have? Then we went one step further. Okay, you're asking us the question, you want to use AI to solve it, not the visual inspection. And now you want to understand the specific element, which is impact driver are allowed to have this much width. Drills are not allowed to have this much width, or they should not have this much weight. So quality assurance system started asking for more data than Litmus Edge originally had, which is what you are manufacturing, why you are manufacturing. So before we do the prompt now, we have to feed with the context of what's going on in the plant floor itself. I'm manufacturing impact driver with 40 volt capacity, not 24 volt capacity. With 40 volt, I have a capacity of running it as 1000 RPM. Your quality assurance needs to know this before it can flag it as a good product versus bad product. Brilliant. I was like, okay, this is what context engineering is built for. And then how do you collect that data? How do you model it? How do you contextualize with the correct information so AI doesn't give you dumb responses, is all what context engineering is all about. Deterministic, I can't really tell that just yet. It's not deterministic, but it is very, very high accuracy if you do context engineering right.
Okay, so I think what I'm hearing from you is that you kind of saw this demand for, going beyond the simple prompt, Copilot, to you had to start, whether it was using RAG or prompt engineering in some form. You were providing additional context. That's kind of what the general AI market has been doing. In the world that that you and I and anyone in industrial systems engineering operates, it's kind of a bit more complex than that, because understanding what is happening in a factory on a production line is very time dependent, right?
Yes.
Very dynamic.
Yeah.
And we don't have the luxury of the large language models having been trained on that data, right? And so in a lot of cases, you're having to provide that context. And so it's a systems engineering approach that needs to not just provide context that we get from, let's say, a unified namespace. That's part of it.
Part of it, yeah.
But there's all this other dynamics, and you want to know what has happened before. You want to know, you may need to use multiple techniques. It's certainly not something that you can expect to handle many of the use cases that we see with a single prompt. There's usually a lot more complexity than that. So am I framing this more or less correctly?
Spot on. Yeah, no, 100% spot on. So it's like as we understand it, if you look at a prompt, you want to solve some hard problem with that prompt. It might not be solving it because it doesn't have understanding of what's going on. So we created a framework internally at Litmus, which is around this context engineering itself, that we had this 50 different customers trying different. So we created this AI workflow engine. We introduced it at a Prove It event last year, and it was built around unified namespace. So we have data from unified namespace. How do you do the prompt chaining to get the result that you want? And then we started seeing that customers were trying, customers were happy with it, but they kept on asking, how can I feed this one more piece of information to this prompt that you're not letting me do right now? And that was pretty eye-opening. So we created this context engineering is a square box with 4 different things that you have to take care of. It did start with what you want to get it done. That might be user prompt, that might be system prompts that you normally enter for any AI activity, which is write a blog for me, create the podcast for me, or create this social media post for me. That's a system prompt, user prompt, and then system prompt, which is attached with that. Then you go one step further, which is what type of memory do they have access to? This is the beautiful thing. We use the word memory in a generic way, but on this assembly line, we just manufactured 500 pieces of impact drivers. That's the memory. How do you enable that memory so it knows what's going on live right now? What's the work order that you are executing? How many workers are working? How many rejections happen? Like a very small list of key values available from unified namespace or available from database doesn't really make any difference. But the idea is that the second thing is memory that you have to attach. So it knows short-term memory. It knows what's going on. The third thing that you attach right after are the tools. Tools like MCP server or just a tool call itself, it's not a mystery anymore, but it's much more look at the SAP and tell me that if I'm doing this work order and these are the parameters, this is the customer purchasing out of this order itself. Not that it's relevant, but for some transportation management system, some other systems, they get very relevant. So the tools and where you get the live data from matters. And the last one itself is they are the user preferences or the guideline that I'm manufacturing impact driver. Stop giving me suggestions for the drill that I'm not manufacturing right now. So eval sets and user preferences, they matter. So once you combine all of those 4 things, your AI output will radically change. And that's what context engineering is all about. What piece of information that you bring in such a repeatable way that your line number 1 and line number 40, they can use the same thing and build this infrastructure that scales. All we care about Litmus is scale. There are a bunch of proof of concept platforms out there in the market. We don't really do that. There are multiple ways to do this. The idea is how do we repeat it across 100 sites is all what we care about. So context engineering became a repetitive things that our engineers started talking about. Let's hold on. ChatGPT is not the answer.
Right. And that's consistent with what we've been saying probably since November 22, right? Which is, it is not the answer to every problem. And I think that's also why we're excited about agents and the fact that you can orchestrate multiple agents as part of that context engineering, right? You have different agents performing different functions. So maybe talk a little bit about how you're thinking about agents and how to use those in the context, no pun intended, of context engineering, right?
Yeah. So I would look at from two different sides. What it is right now, and what would I like it to be?
Right.
Let's say it's currently like a vision on what I would like to be is really a purpose-built agents which are created to solve one problem in a consistent way. And a swarm of those agents, they are orchestrated in a manufacturing facility to take care of the tasks which are predefined. It keeps on evolving. It helps people on the ground to solve those problems faster. That's what I would like to be. What it is right now is in the cloud environment, the resources are abundant. So there are there's a lot of compute available for you to run those AI agents. I want to create doc. I want to create a blog. I want to do XYZ on a financial analysis. There are lots of agents available. If you go to manufacturing, you are in a constrained environment. You are restricted from the cloud, air-gapped infrastructure. So it's not possible to run it. So SLMs came in. SLMs, they started hallucinating a lot. So the idea is, how do we bring this cloud native components on from the one that you run on a fabric? I want to bring it back to edge. And I want to bring it to in front of the people, they can use it. So in agentic AI workflow, cloud is currently necessary. Partners like, again, we work with Azure, AWS, GCP, Databricks, 4 of the largest consumer of industrial data or data fabric itself. And they can run those agents. How can we extend them to edge and they can run the exact same agents locally? And it will happen. It will happen maybe in the new NVIDIA systems which are getting launched. It will make it democratized. The Thor just opened up for robotic purposes. So we have some customers trying that out, running Litmus Edge and running autonomous AI agents locally. But it's just so much technical complexity that I don't think people are getting the value that they want.
Yeah, and you raise some interesting, and we've talked about this on earlier episodes as well, kind of what you can almost assume at the enterprise you can't assume at the factory level because of security, air gapping, latency, accuracy, as you pointed out. And you kind of used LLMs and SLMs. I think when we talk about industrial AI at ARC, we tend to assume, or not assume, in fact, we don't assume that it is going to be Gen AI when it's AI. It could be an ML technique that we've been using for decades. It could be a computer vision model. It could be we have a much broader toolbox when we think about industrial AI, and many of those are better answers, more cost effective, more accurate. So when I think about agentic AI and even the AI on the end of that, I tend to think of agents, and some of them may use AI and many of them may not use Gen AI. They may use a trained model for predictive analytics, right, anomaly detection, which may not use Gen AI at all. They may be retrieval agents, right? They may be heuristics based. I mean, so I tend to feel like we all fall into agents having to be AI.
Yeah. No.
I tend to think about the term, which is one of the reasons I didn't really like agentic AI, but like, everybody else, I'm kind of forced to use the marketing term, right? But I think agents do open up, and in many ways they are a logical evolution of architectural waves we've gone through before. I think I've said it before. I remember object technology, and we kind of had to agree on, right, how do objects communicate and how granular are those objects going to be, right?
Yeah.
Feels like we're in that same stage now in the era of AI, but I also think agents start to play some role in edge to cloud, right?
It does. Yeah.
What could be run in the cloud and what runs on the edge and how are they orchestrated is not an either or. It could be a collaborative process, right? Running across multiple layers of the old ISA model, right? Or whatever that new model starts to look like. And all of that is systems engineering. So I do like the term context engineering, and I think it brought me back to thinking about what we all intuitively understand, that simple prompts using LLMs are not really going to solve a lot of our use cases or potential use cases for the broader scale deployment, as you just mentioned, of AI enhanced or augmented solutions for productivity and quality and cost reduction, etc., in the industrial sector.
Yeah, no, like 100%. And I think I remember your diagram, the OT, IT, and then there is a circle in the middle of it, where you talked about application data fabric. That was a creative use of the word itself. We have applications, they are getting built in the cloud native world. So if you ask, it doesn't matter, manufacturing companies and their IT teams, how are you building your application? They will tell, I have a Visual Studio, I have Visual Studio Code, I'm going to write it. Where are you going to author it? Oh, the easiest way for me to push this is to this cloud hosted application hosting environment. Okay, how are you going to bring it back to edge? Your models are different, interfaces are different, your runtimes are different, databases are different. This hyper-converged infrastructure that you create, where asset twins, they are available on the edge, the same asset twin is available in the cloud, and then you create that environment where applications are completely fluid. This will be necessary for agentic applications to work. Sometimes they will run in the cloud, sometimes they will run at the edge. Right. It has to be completely fluid. And I think like we are all talking same thing, different labels, but the idea is this IT OT divide that we have. I think it's like for leading companies that use Litmus, they don't have that divide anymore. It just, there is a general understanding, some data here, some data here. These are the business problems. Let's just tackle it down. Fabric is the best way to do it.
Yeah. What else? You also mentioned Thor and NVIDIA's role, right? That maybe we're going to get a bit more power and attention, right? Paid to edge deployments and whatever models get used on the edge. Now, some of that clearly in NVIDIA's case is, I wouldn't say it's dedicated to their idea of physical intelligence and robotics on the edge. It's much more broadly applicable than that, but obviously that's what the marketing is behind, right? But I think it does have huge potential positive impacts on what we can run inside factories, overcoming many of the security challenges, latency challenges, and giving us power where we need it.
And sometimes cost challenges as well. And like I think like hyperscalers, let's say if you talk about Google introduced Google Anthos. So you can bring the same interfaces that you run in the cloud, you can bring it inside Edge, Azure local. Take Azure interface, you bring it inside Edge environment. So they are trying to come down. They are trying to come down to the plant floor and bring the interfaces, APIs that they have in the cloud. So then once again, next generation of applications, they are going to be fluid. Edge cloud, they are going to get hyper-converged sooner or later, if cost.
Yeah, I think when you look at the hyperscalers, they're all trying to work on control planes. That maybe the control plane is in the cloud, but yes, make sure that you have that flexibility on where you deploy the runtimes on the edge, right? But they still, I think they're still making their biggest bets in the cloud, and that you're still going to want to manage, particularly for large scale deployments, scalability across devices that are highly distributed. And I guess that makes sense for many, many of us, that if we can get the benefits of the latency and the power deployed on the edge, then we're okay with configuration and lifecycle management perhaps being cloud-based.
Yeah, and for sure. And I think there is still a place. So like, let's take an example for Mosaic, ML, or Databricks itself. That the prime use case that they have is the data fabric. So collect data from hundreds of manufacturing sites. We are already pushing that in Databricks environment. Now Databricks has two options. One of the option is run the advanced analytics in the cloud. That might be one of the option. Or create a data lake type of infrastructure where you can create medallion architecture from bronze, silver, gold. So you are having some applications in a distributed way, some applications in central way. And they might be the perfect guideline on how do you make this ML interfaces in the cloud, ML interfaces at the edge, still have the same control plane, governance on the top of it. Data fabric will evolve towards this anyways.
Yeah. And I kind of have spent a lot of time with Databricks and some of the alliances being formed. And I noticed that you appeared on their latest industrial AI reference architecture, if I recall right. They just published that a couple of weeks ago. So yeah.
Yeah, we have been working with Databricks. The one of the things that Databricks got very right is in manufacturing world, you can't transport all the data out of the plant into the cloud environment. That doesn't happen. So creating a data lake type of infrastructure where governance or Unity catalog is still centrally done. New data can be pushed there, but data can stay in place. You don't have to keep on moving to get results out of it. So
I think that one of the other things they got right, and it's kind of triggering my next question for you, Vatsal, is really obviously their roots are in kind of open source and they've struck a nice balance of kind of driving standards. Obviously they are starting to monetize it quite effectively, right? Yeah. But I think a lot of their popularity does stem from their approach of driving open source and in many cases kind of continuing to offer up new capabilities that the community can support as a whole, which kind of leads me on to, I think part of, as we see scale and trying to work out how you context engineering needs, in many ways, standards, interoperability, for it to really work. And that's where I think I got into MCP and its potential fairly on. Not that it replaces OPC UA or anything else, but it is providing some new capabilities that we need in this new era of AI. And then I was excited when A2A came along and the community kind of committed to supporting A2A. And they're certainly not mature. We know there are identity security challenges with those that need to be addressed. We know that and there are already extensions to A2A, and you have which was GCP that kind of drove that, but AWS with Strands is doing some interesting things as well. So I think there's still plenty of room for innovation and progress on those standards. But where do you see, I love to hear from you as well on Litmus's specific support for those and where you think those are going to help or need further maturation and how you're kind of working with those where they make sense.
Yeah, no, for sure. I think we are in early days. We keep on telling, even after 2 years, we are still in very early days of all these innovations. We keep on saying a new model getting released every other day, or a new approach, new interface, new search APIs, everything keeps on opening up every other day. And they all claim to be significantly more powerful than the previous generation before. So that's just a reality of innovations on AI. Now, some of the things they are getting very set in stones, like MCP servers. We introduced MCP server quite a while back. As a part of Litmus, we already had publicly available REST API. So creating a MCP layer on the top of it was pretty straightforward. Found it on GitHub. We let customers use it. But to what end? What customers would do with it? The goal for MCP in future is to orchestrate multiple different systems, understand multiple different sources of truth, combine it, and drive some results out of it. So AI agents, where they run, how all of these MCP servers they connect, how do you authorize, how do you authenticate? You can't give admin APIs to MCP server. That's just one of the worst thing to do. So how do you secure this whole control plane before you expose MCP is one of the biggest challenge. Proof of concepts, they are done dime a dozen. Like everybody's playing with MCP servers around Litmus right now. Right. But would I advise them to put it in production? Not until they know how you're going to have federated authentication. How are you going to control it? How are you going to manage the API keys that you are giving it to server-side authentications or other MCP servers? So MCP A2A, huge leap forward, but there are enterprise grade things that has to be fixed before it can be mass commercialized. That's once again.
And you use enterprise grade, but I tend to think, and I'll bring it back to what you do as part of your core solution offerings is really that, to your point, you're providing multi-factory scale, right, with contextualized data. And yes, a lot of it may be perceived as being factory-centric as opposed to a full all the way to the enterprise, right? Although you do provide a lot of that connectivity as well, I believe. But I think that's an important foundation and kind of why I wanted to go down this path, right? Which is I kind of needed to, I think, talk to everybody, make sure that everybody, not so much in the OT world, but in the IT, ET, and data science domains, understood what we're dealing with in factories, the complexity, the fact that data, most cases, sure, we could give them terabytes of data, but they wouldn't have any context. They wouldn't know what to do with it. They wouldn't want to pay the cost of moving it all to a data lake, and a data scientist wouldn't know what to do with it.
No, absolutely.
So I kind of got into the data fabric foundations coverage primarily because I could see that problem starting to get more attention. And I'm sure you're seeing it as well, a lot more interest from clients on solving data quality problems, adding context to data. And a lot of it is being driven by the AI potential, right? But we're not there yet, right? And that's in many ways is what's holding us up. Unless you put these foundations in and solve the context of the factory data, that won't be unlocked for use by not just the factory, but supply chain or enterprise or the engineers who want to mine that data for what should future designs look like. And so we've got to crack that code for everybody else to be able to tap into the fact that we generate more data in the factory than the rest of the business combined, right?
Yeah. No, for sure. Again, thank you for bringing me back to the point itself. So the idea here is Litmus was founded to solve that problem. So Litmus as a company, when we started saying it, so currently we are deployed tens of thousands of sites all across the world, anywhere from energy, oil and gas, energy, food and beverage. Food and beverage is one of our core segment. You go to cheese manufacturer, you're going to find Litmus. You go to water bottles, you go to soda, beer, you're going to find Litmus. So the idea here is we had, what we were selling was the foundational data platform. That's all what we, when we get in front of users, what do you want? I would like to collect data from my control systems. So we became one of the best ones in the world. There are legacy approaches. The systems which are created in 1990s, they still exist. But can you build your future on those systems? 100% no. So customers are dumping it day by day. So we don't start with the replacements of some of these legacy systems, but that's where customers end up with because they want to maintain it. So the first thing that we do is we tap into the control systems natively, one of the largest data pool. But at day, let's say 1 of Litmus was really data coming from Rockwell or data coming from Aspen or data coming from Siemens or Yokogawa DCS needs to look exactly same. There was no AI. I'm talking about 7 years ago.
Sure. Yep. This is a lot of what Rick and I were kind of spending the first couple of episodes in this series talking about. It was that legacy problem that we have to solve before we can monetize new solutions on AI.
Exactly. And so I come to the multi-vendor approach on the other side. But the idea here is you have to tap into that data because that's the cleanest source of the data that exists, or you have access to clean it up. So that's what Litmus started doing, which is we started collecting data from control systems. We took the hard problem head on. If you come to our Santa Clara office, we have every control system from 1970s up to this point on the wall. We purchase everything out there. So we started there, but that is just a 20% of Litmus product. So we collected all the data, we cleaned it up. How do you contextualize that data with real information? How do you analyze that data? How do you make data available to third-party application? How do you, once you do all of this, how do you take the successful blueprint and put it on a 200 other facility or 5,000 other facilities? That became the biggest challenge. So we kept on asking customers, what's next? What's next? What do you want next? What do you want? So that we kept on building the feedback-driven roadmap, and where we ended up, again in 2022, we had a couple of customers, they were using our product for 4 years in. It took literally turn on the switch for them to enable AI. because it was already clean, contextualized, all data, all managed centrally, everything was available. There was like for them, they actually send us letters of appreciation that we are going to be on the first one in on the AI train because we had that data available. Now, customers getting started now, they are not late. We are still in the earlier times of this AI right now. So from 2022, 2021 onwards, customers started going wild on fixing up the data foundation. Of course, the data exists, or we sometimes pretend that data exists. Oh, I have this OPC UA servers, or I have this data broker product in the plant floor, or I'm going to purchase this open source and I'm going to do it. None of those things, they are your core business. Your core business is to enable business applications or business AI that reduces the cost or increases the revenue. There are only two factors. Everything else is a distraction. So are you going to purchase 4 different vendors, or are you going to get things done right now, is the question that we normally ask. And customers which are serious about their data, they don't mess around with 15 different products to get 1% in revenue increment.
I kind of wanted to bring us back a little bit to the fact that there is now this, you're solving some of the data foundation issues, and there is now this potential that we can actually do more context engineering. Yeah. So I guess the question is, are we going to see the rise of a new role? Because I've been talking about this idea of industrial grade data scientists, right? Not that many of those really exist. It tends to be, two different. I've got people that understand the industrial domain, and I've got data scientists. And if I work really hard, I can give them some common data foundations and persuade them to collaborate, right? So I don't know that I would really still stick to that idea that we have industrial grade data scientists, but I have met real-time systems architects, right?
Yep.
And so I could see this idea of industrial context engineers taking a little bit more hold, and that there are specific roles in the organization where it's not just about they have to work with real-time data and it's for an internal audience. Their job is to provide industrial context outside of OT, not just OT, but to IT, ET, data scientists. So how do you think about that? Would you agree with that, or are you starting to see it, or do you?
I would say in a short term, I would agree with that, because that will solve the fundamental problem of providing the context itself. But as the systems or AI agents, they are getting smarter. Let me answer that question with reality. There is a deep learning algorithm to build relationship of the assets. That's what we created. So what we did was, here is the boiler, and here is the vendor of that boiler, and here is the manual. By using deep learning, no AI, nothing fancy, can you build the relationship between these two? And it did. Just a pure neural net. So now, can I see that in future, there will be a context engineering agent that pops up, and then that builds the relationship, adds the data to make it more relevant, to get close to the eval sets that customers have. I think future might be a little bit more automated, but that's, again, I'm optimistic about it. I don't know if it will happen or not, but short term.
I don't disagree with you, Vatsal. I think I've speculated the same, that for the same reason, I'll be honest, I never really got deep into prompt engineering, because I felt like, they're getting more and more intelligent, so they can understand what I'm asking for without me having to learn a specific language, right? And so I think agents will get more intelligent. I do think they will get more intelligent only if industrial domain experts get involved, right?
Exactly.
But once they get involved and apply the technology, then yes, over time, I think, just like prompt engineering is not a discipline that I think is necessarily going to be earning hundreds of thousands of dollars in future, right?
No, for sure. But your point, industrial grade data scientist is still one of the huge gap. Somebody that understands maths, somebody that understands physics of assets itself, it's a rare position. It doesn't exist a lot. So companies, they started creating this combo teams. Industry 4.0 team, blended as Industry 4.0 team. They will put 1 or 2 data scientists, and they will put 1 or 2 subject matter experts, and they will give them, here's the problem, write up the formula on one side, write up the logic on the other side. I've seen successfully done it. So one person replacing it, maybe that's a unicorn.
Again, it's what we're seeing. We're seeing kind of centers of excellence, right, where you're kind of mixing those roles. But no, we don't see many industrial grade data scientists being embodied in a single person. It does tend to be a team, right?
Yeah, exactly. But like if you think about it, isn't that just a progress on its own? Data scientists, they never cared about manufacturing in the first place. Now they are excited about solving some cyber physical problem. In my mind, that's just beautiful. They were solving financial problems, supply chain problem. Now they are coming back to the ground. The heart of the company, manufacturing company, is the plant. They are coming back and solving the hard problems.
It's a fantastic point to make, Vatsal. I get excited. I still get naysayers who say we've made no progress on IT and OT convergence, and I disagree, right? We're seeing a lot of collaboration now across IT, OT, and data science, right? We do see these centers of excellence, which to me is, to your point, tremendous progress. And we're seeing the money going towards solving factory problems, right? And so I'm optimistic like you.
Yeah, and some of these things I see, and I find it beautiful. It's just like somebody that has a deep awareness of neural net coming to the plant floor and telling, oh wow, we can build relationships across our plant like this. I was like, I don't really care what the result is. I really want to see what you're thinking, because we never know. We never know what they might come up with. So
really sharing what you think is the most important advice, if you've got, that 1 or 2 minute pitch where you really want to land a point with somebody and say, if you do nothing else, this is what you should do. Here's your opportunity to do it, Vatsal.
Yeah. So like over time, what we have learned working with customers, that the roadmap matters. You can't get everything done today, even if you wish to. There's a change management is a fundamental element in the manufacturing. So it's required. Broader consensus is required. So leaders, the successful leaders, they are making a roadmap. A roadmap is divided into solving the foundational data problem. Not building the tools, but we want to understand our data better. We want to understand what we have. We want to understand what we own already. Who has it? Then they go for, how can I use it? Use the subject matter experts, involve them. The first 3 months is to, probably if you're fast, then first month is to solve the data. Next few months is to solve a real problem. And then keep on forwarding it further until you find 100% repeatable answer to get one of those 2 business problems, increasing revenue, decreasing cost. And how do you get that? It requires a roadmap. And if you don't do anything right now, just figure out, just think it through. How do I introduce this change without AI in my manufacturing facility, and think at scale? How do I scale it up across my 100 sites? And the answer would be never create product, because your 100 site problem is $100 million problem versus purchasing tools to solve 1 or 2 small problems that is not going to drive any innovation in the industry. So the whole idea is create a roadmap, start right now. Downloadable products like Litmus, just download, install, cybersecurity, done, collect, connect, contextualize the data, analyze it, enable AI right after. Do something. Just don't
do nothing.
Yeah. Do nothing, and your competitors are already doing 10 times. Right. Things that fail matters. So they are already doing.
All right. Thanks, Vatsal. And I've been talking with Vatsal Shah, CEO and co-founder of Litmus Automation. So thank you, Vatsal, for all of your insights. And I love the fact that you were talking about time to value in not years, right? So I think that's important and shows how the market is evolving rapidly. So thanks, and hope everyone enjoyed the conversation. And I've got a feeling we'll talk again at some point in the future, Vatsal. So thanks very much.
Thanks a lot, Colin, for having me. Thank you.